Hi, you guys. Welcome back to chapter 8. So, due to you guys gonna have a SAC soon, so what we do is we're gonna start the chapter 8 today. So give you guys a quick minute to revise the what we just did in year 11 last year, and then what we're gonna start with some matrices, some representations first. And once we're done that, and we're gonna tell you guys what's the type of the matrices looks like, and then what kind of the matrices we actually gonna go through. Um, so this chapter pretty much gonna have a 6 videos in total. Fingers crossed we are gonna get A's on next sack. So let's have a look at the type of matrices first. So matrices which is numbers, rows, and columns together. So each matrices are representing the each element on the matrices. For example, if I have 2 by 2 matrices, we have each numbers on the each elements on the each column and rows. So normally we are saying the matrices, we always saying rows first. So what's the rows means, which is we're going to how many rows it horizontally goes, and what's the column, which is vertically how many columns we have. So for example, if I say 3 by 2 matrices, order is 3 rows, 2 columns. This is a 3 by 2 matrices. We can say it's 3 rows, 2 columns. And if I ask you guys what's the A21 means, that means what's the elements on the row 2, column 1, so which is -1. This is how that works. Fingers crossed that actually makes sense. And now we're gonna talk about what is the row matrices. Row matrices is like one row, but how many columns we don't know, like 1 by n matrices. Column matrices, which means one column, but how many rows we don't know. So it could be 4, could be 5, could be 10. So matrices are actually sometimes we call the square matrices, which means same column, same row. So same row, same column. And the diagonal matrices, which is we have all those numbers are 0 except for the diagonal line, which is 3, 7, 5, 6. We can see. So that's called diagonals. Zero matrices means all zeros. Hopefully that makes sense for you guys. All right. The kind of important thing to understand is transpose. Transpose matrices means rows and columns are switching. So if we have A equal to 1, 0, 2, 4, and 2, negative 1, 3, 5, we are switching the columns and rows. This is 2 by 4, and we switch to 4 by 2. So that's kind of like a kind of is called representing A to the power T. That means transpose. So 1, 0, 2, 4 to become the vertical, and 2, negative 1, 3, 5 become to the vertical as well. So that's called the transpose. All right, some symmetrical matrices. So symmetrical matrices means the matrix A is symmetric if A equal to the transpose A. So which means elements are meaning diagonals the symmetric with the matrix when the A ij, which is I representing row, j representing column, equal to AJI, which is your row become your columns number, your columns number become rows number, still the same number. So we can say, if I say column 2, 1, which is 3, and column 1, 2 is 3. So that's why we call transpose. If you transpose that to horizontally, we can say 1, 3, negative 7, 1, 3, negative 7, we transpose is still the same. So that's why it's called triangular matrices as well. If I say it's a square matrices. Um, okay, now we're gonna talk about something with the to find the 2, 1 elements position. So which numbers on the 3 is on the x11? So which is first one will be 1 row and 1 column. Second one will be 1 row but 2 columns, which is 1, 2. C nothing, which is none of them is a position. 3 on here will be 3 and 3, so which is 133. So last one will be 113. So that's how it works. Sometimes we are using the table to translate to the matrices as well. We label the 2, 23, 17, 23, 17, and so on and so on. The clearly this is a symmetrical matrices if I do that. So let's have a look at this. Hopefully you guys still remember the networks, and then we're doing networks in here to generate the matrices. So once we have that, let's have a look. So what's the age means? That means we're going to somewhere. So A to B, we have one row, you're going to one route. So A to B, so we have 1 and 1, so that's why I highlight here. Here. So we don't have 1 to C, so that's why it's 0, 0. So we don't have A to A, that's why it's 0, 0 as well. But we have 1 to D, so which is D to 1, 1 to D will be 1 and 1. And A to E, there's no direct. So we can't have a direct age. You have to put the 0. You have to put the 0. So now next one. So if I have to B to 1, so we do have a B to 1. Do I have B to B? Yes, we have a loop. Loop means you come back. So directly come back. And then we don't have B to C, we have B to D, we have B to E. So that's how we're creating. And the funny part is D to E, E to D. So this is have 3 root, so that's why I have 3 here. And so we have isolating vertices, which is C. So we don't have any connections between those. That means like that's an island. So it's like a if you going somewhere, going to the island, you have to take maybe I don't know plane. You can't take a road. So that's like for example. All right, next one, we're just creating the social class. We have 2 by 2 matrices can translate to 3 by 3. That means 3 by 2 matrices can be finding as well. Also, we can using the word equations to find out the answer by the matrices. So please pause it and then have a look at the C and B. Hopefully that makes sense. Now what we do is we're gonna creating the exam questions. So some exam questions are using as transpose matrices. So first one, if I say 3A13, we translate straight away to the 3A13 in top, and then that will be the answer. So that's how that works. Kai was like part-time job. Each weeks we have some money, and earns E, save S. So 3 weeks, perfect. And then now we're gonna how much they save it for week 2. Save is S, week 2 is 90, so we save for $90. Let M equal to that, and then we have something elements I and J. So what's the element determine the rule? So let's have a look. Imagine that if I had, that means M1, 1 equal to 1. So that means I equal to 1, J equal to 1. So once you have that, let's have a look which one is correct. If all correct, we move to on the next. So first one, I equal to 1 plus 1 minus 1 equal to 1. That's correct. And 1 plus 2 minus 2 equal to 1 as well. And 1 plus 1 plus 1, that's equal to 3, so that's not correct. 2 plus 1, 2 times 1 plus, minus 1 plus 1, that's 2, so that's not correct. And 2 times 1 plus 1 minus 2, so which is 3 minus 2 equal to 1, so we have 3 in the end. So now let's move on to next. So if A, D, and C is correct at the moment, so we try another one maybe. We try M2, 1. Let's see. I equal to 2, J equal to 1. So first one, I equal to J, so 2 plus 1 minus 1 equal to 2, so that's not correct. Let's try C. So 2 times 2 plus 1 minus 2, that equal to 5 minus 2 equal to 3. So that's correct. And next one, 1 plus 2, which is, 2 plus 2 equal to 4 minus 2 equal to 2. So that's not correct. The answer is C. So hopefully that makes sense. Not too hard to start beginning. And then we move on to the next chapter. Sorry, move on to the next video. See you guys.